Welcome! The third apparatus comprising the Supercam is the visible and infrared or VISIR spectroscopy instrument. For nearby observations, VISIR uses the same red laser that is used by LIBS. For faraway observations, VISIR uses the visible and infrared rays from sunlight. VISIR uses the reflected visible and infrared light spectra to determine the mineralogical and molecular structure of the sample. It is highly sensitive in analyzing clays or minerals that form in water. Visible and infrared spectroscopy has been flown before in planetary missions such as the Cassini mission and the Mars Reconnaissance Orbiter or MRO, which is currently in orbit around Mars. The instrument on MRO is called CRISM, which stands for Compact Reconnaissance Imaging Spectrometer for Mars. This image was provided by CRISM instrument and shows how the various mineral assemblages are mapped on the surface of Jezero crater, where the Perseverance rover is presently studying. All infrared spectroscopy so far have been done in orbit. This is the very first time that it will be used on the surface. VISIR on Supercam is a long-range instrument. It can analyze objects kilometers away as far as it can see on the horizon on Mars, unless the atmosphere is hazy, which is the case during dust storms. This is useful because scientists will have preliminary scouting information and will have an idea of what they can expect to find once the rover gets to that place. VISIR can be pointed upwards to observe and characterize the atmosphere. It can measure the precise atmospheric abundances of oxygen, carbon dioxide, carbon monoxide, ozone, and water. This is an example of infrared spectra taken by the VISIR instrument during testing on Earth. It shows the unique fingerprints of the different minerals such as magnesite, siderite, aragonite, and so on. The type of clays that will be found by VISIR will tell the story of water on Mars millions, if not billions of years ago, and would provide insights into its past habitability and the probability that ancient life once existed on Mars. The next instrument as part of the Supercam is the time-resolved luminescence spectroscopy or TRL. TRL uses the same green laser that the Raman instrument uses. Luminescence, or more specifically photoluminescence, is the emission of light as a result of the absorption of photons of a higher frequency. For example, objects glow in visible light when exposed to ultraviolet light. This phenomena is categorized as either fast or slow. The fast response is called fluorescence, with typical lifetimes of picoseconds to nanoseconds. This is exhibited by biological or organic materials. The slow response is called phosphorescence, with typical lifetimes of microseconds to milliseconds or even longer. This is exhibited by many inorganic minerals caused by defects or the presence of atoms of transition metals or rare earth elements. An example of fluorescence is the glowing of your teeth in dark disco rooms when the UV strobe lights are turned on. An example of phosphorescence is the glowing of your watch dials when entering inside a movie house. The TRL instrument can also be called TRF or time-resolved fluorescence because we are more interested in finding organic or biogenic molecules. The time difference between the fast glowing organics versus the much delayed glow of inorganic minerals is exploited by the TRF instrument by having a time gate that closes after a certain period of time. By default, this timer is set at 100 nanoseconds. This effectively filters out all mineral luminescence. This timer can be set to longer values if the transition metal and rare earth element components of the target is analyzed. A version of Supercam TRF instrument has been tested at the University of Hawaii, showing this result. This is a mixture of sand grains as viewed in visible light. Now this same material as viewed by TRF instrument. Here we see the two images together. It turns out the grains that are seen by the TRF are eroded coral skeleton pieces, mostly biogenic calcite and aragonite. Even if the sand grains contain luminescent ruby or zircon, they won't show up in the TRF image because all mineral luminescence are filtered out. Only objects that are of biological origin are seen. This is amazing. This is a game changer. Now we have an instrument that can detect both extant and remnants of past life without even touching the surface. This instrument can be used not only on Mars but in places like Ceres, Europa, and Enceladus. The next instrument in the Supercam toolbox is the Remote Micro Imager, or RMI. This is a telescopic camera which takes clear high-resolution images to get the context and the precise locations of measurements made by the different spectrographs. This instrument is an upgraded version of the ChemCam RMI on the Curiosity rover. This is a picture taken by the ChemCam RMI. At the bottom it shows a vein of calcium sulfate. At the top is a close-up image of the same vein, showing the percentages of boron at each point of the raster made by the LIBS instrument. In this way, scientists can identify how boron is distributed along the vein. RMI is also used to take clear high-resolution pictures of objects that are kilometers away. It can resolve the individual layers and bedding of sedimentary structures. This picture of Ingenuity helicopter was taken by the RMI camera. The sixth instrument comprising the Supercam is the microphone. The microphone is located just below the big eye of Supercam. It is a Knowles electret microphone. The acoustic signals that it hears provides information on the physical properties such as hardness and density of the rock target. This is similar to listening to the sound of a watermelon when you tap it to know if it is juicy inside. All these six instruments comprising the Supercam complement each other. They work simultaneously and explore the different qualities of the target. In this picture, we see a rock that was scrutinized by the instruments. The yellow arrows point to the raster holes made by the LIBS instrument. While these holes were being zapped, the sound was being recorded by the microphone. These blasts cleared the rock surface of dust as outlined by the yellow circle. The green arrow points to the green spot where the Raman instrument looked into, and the red arrow points to the section where the VISIR probed the surface. All the while, the RMI took this whole image. The synergy of the results of these instruments will create a strong and compelling scientific basis enabling mission critical decisions as to which samples will be collected for eventual return to Earth. The profound fusion and combination of these results will venture to fathom the thickening mystery. Is there life on Mars?